Hi everybody, today we're going to talk about some basic geometric objects and their definitions. Here we have three geometric objects on the screen. What observations can you make about them? What are the similarities and differences between the objects? Also, see if you can try to name each object. Take a minute, write down what you think. The first geometric object we have here is a line segment. You might have seen that it has two endpoints, one on each side. It seems to start and stop at a certain point. The second geometric object here is called a line. It has arrows on both ends and it goes infinitely to both the left and the right. It extends infinitely forever in both directions. That's what the arrows mean. And finally, we have array. Array has an arrow on one end and an endpoint on the other end. It goes infinitely in just one direction. Here you'll notice that there is a line segment on top of the ruler. Take a second and try to name this line segment. If you said either line segment CD or line segment DC, you were absolutely correct. We name line segments with two letters, one for each of the endpoints. It doesn't matter which order we put those letters in, as long as we're naming line segments with two letters for the two endpoints. We do have notation for line segments, and that's a little bar symbol over the name of the line segment. So this would read line segment CD or line segment DC. So that notation on top is important. The second question says, which points are labeled on this line segment? As we can see, points C and D are the ones that are labeled here. We use those to help us name the line segment. Can there be additional points on the line segment? Or are C and D the only points that exist on this line segment? Take a minute, write down your thoughts. If you said that there could be other points on this line segment besides just points C and D, well, you are absolutely correct. If we wanted to, we can make another point right here on line segment CD. We can make another point, oops, that doesn't look like much of a point, but we can get another point over here. We can make another point over here. And if we wanted to put a point in between the first and second, we could. In between the second and third, we could. We could put a point over here. We can keep getting smaller and smaller if I had something smaller to write with. And we can get more and more points on this line segment in between C and D. In fact, there are an infinite number of points that you can make in between C and D. But it's important just to know that there are more points on this line segment besides only C and D. There are tons and tons and lots, and actually an infinite number of points that exist here. Can we measure this line segment? What do you think? We can measure this line segment. The reason that we can measure a line segment is because it has two endpoints. It does have a starting and a stopping point. So that means the whole line segment is measurable because it only takes up a certain amount of space. So we could actually look at the ruler. C is at 0, which makes our life a lot easier. And we can see where D is. It's at about 7¼ inches. I think that's the inches side. I'm just going to write here about 7¼ That ruler is really hard to read. I should have got a better picture of a ruler. But there we go. It's about 7¼ The important thing is you can measure a line segment because it only takes up a certain amount of space from endpoint to endpoint. Find the measure of line segment AB and line segment CD. What do you notice? Take a minute and write down the measurements of AB and CD. I'm going to write them down over here. Line segment AB measures 1, 2, 3 spaces. And line segment CD measures 1, 2, 3 spaces. Notice that I didn't put the bar notation over the line segment name this time. That's because when we're talking about measurement of the line segments, we leave that notation off. So this over here is actually read as the measure of AB instead of line segment AB. So the measure of AB is equal to 3. The measure of CD is equal to 3. So notation is important. I know it could get a little bit tricky at first. When you're talking about the line segment is equal to a certain number, don't put the bar on top. When you're just talking about the line segment itself, not using numbers, put the bar on top. What do you notice about the lengths of AB and CD? You might have said that they are equal. They definitely are. And in geometry, we have a word for equal in size, shape, length, all of that stuff that's going to come up a lot. And that's the word congruent. And we have a symbol for the word congruent. It's an equal sign with like a squiggle on top. So we can actually say line segment AB and line segment CD are congruent to each other or equal in measurement. Take a minute and find the midpoint of this line segment, whatever you think it is. If you said 1, you are absolutely correct. The reason that 1 is the midpoint of the line segment is because you can think of midpoints as exactly in the middle, the point that's equally in half of the line segment. So there's an equal number of spaces to the right of the midpoint and an equal number of spaces to the left of the midpoint. It's equidistant from both of the endpoints. Notice that there's 2 spaces to the left, 2 spaces to the right. That's how we know for sure this one's exactly in the middle. The next question tells us that a bisector cuts a line segment into 2 equal parts. How would we draw the line that bisects the above line segment? Well, it's pretty simple. Since it's a line that cuts this line segment exactly in half, it's going to pass through the midpoint, which is 1. So all I need to do is draw a line that goes through the midpoint. And there we have the bisector of this line segment. It's a line that cuts the line segment exactly in half because it passes through the midpoint of that line segment. How can we name this line? Just like with a line segment, we name a line with 2 points as well. Since here on this line, there are more than 2 points, we can pick any 2 points, and it doesn't matter the order. So we can name this as line AB, or as line BC, or as line CB, or as line BA, or even as line AC. When I missed one, or CA. I think I got them all this time. To let the people reading our work know that we're talking about a line this time instead of a line segment because we named it with 2 letters, we're going to put different notation on top that lets everybody know for sure that we're talking about a line here. And that's a little double arrow on top. That is, oh, I put it over the or. There, let me fix that. That double arrow symbol signifies that we are talking about a line because a line goes infinitely in both directions. It has an arrow on each end. And that's why we're able to name a line using any of its 2 points in any order. Because since it goes forever to the left and forever to the right, it doesn't matter in which order we name it because there's no start and stop. It goes forever in both directions. What is the measure of this line? How can we find it? You might be wondering and thinking this is a trick question, and you're absolutely right. It is. Since a line goes forever to the left and forever to the right, you can't measure it. There's no clear start and stop point because if we took a ruler and we measured what we see here on the screen from here to here, well, we're not getting the whole line because the line has an arrow on the end. So it's going to keep going forever and forever and even off my computer screen in both directions. So we're never going to get an accurate measure of the line because it goes on infinitely. There's no way to measure it. Let me make that a bit neater. There we go. So I'm going to write here You can't. A line goes infinitely forever in both directions. How can we describe the location of points B and C on the line? Well, in words, how would you describe it? The best way for me to describe this would be that point B is between points A and C. Between is a word that we have here in geometry, and it means exactly what it means in English. That point B can be found somewhere between points A and C. So that tells everybody if you're drawing a diagram and you know that point B is between point A and C, that when you make point A and you make point B should be somewhere in between the two. So keep that in mind. And finally, we have our third geometric object, array. Notice how it has an endpoint on one end and an arrow on the other end. Lets us know that we have array here. How can we name this array? So we name array with two letters, and I'm going to give you one name for this array. I'm going to name it ray AB. I see point A here, and I see point B here. And I'm going to put the notation for ray on the top. As you might have guessed, it's an arrow going in one direction because array only has an arrow going in one direction. Or ray BA. Now here's the question for you guys. Do you think ray BA is a valid name for this ray? And put a reason why, or why not. The answer is that BA is actually not a valid name for this ray. And the reason for that is because array only extends infinitely in one direction. Here, this ray is going only to the right. It starts at this endpoint over here and it goes forever to the right. So it actually has direction. This one is going to the right. So that means when we name it, we have to name it to the right, starting with A and then B. Can this ray be measured? What do you think? Well, although we know where it starts, we know where the endpoint is over here, array does have an arrow in one direction, so it goes forever in that direction. So even though we can measure from here to here, we're still not getting the whole ray because the ray is going to keep going and going and going in this direction forever off my computer screen and forever and ever. So no, we cannot measure a ray for the same reason that we cannot measure a line. If there is an arrow, it means it goes on infinitely forever in that direction, so we can't get a full measurement of it. Here's some practice questions. Try them out for yourself, and then I'll write the answer on the screen. So the first one's pretty simple. Midpoints are equidistant from both of the endpoints here. So 5 is 9 spaces away from 14. So 23 is 9 more spaces away from 14. So 23 should be the x value of q here. The second one's a little bit trickier, so we'll go through it together. So B is the midpoint of line segment AC, so it's exactly in the center. So what that tells us is that from A to B, AB is the same as from B to C. So I'm just putting these two little tick marks over here. That lets us know that they're equal, that they're congruent to each other, this half and this half. So since we know that this part AB is equal to this part BC, since B is the midpoint, all we need to do is set these equal to each other because they should have the same measurement. So I just set up an equation over here that says 4x minus 5, which is AB, should be equal to 2x plus 9, which is BC. Solving the equation, let's add 5 to both sides. We have 4x is equal to 2x plus 14. Let's subtract 2x from both sides. We have 2x is equal to 14. And finally, let's divide by 2 on both sides. We have x is equal to 7. It also says to find AB, BC, and AC. In order to find that, all you need to do is take the x value that we just found together, 7, and plug it in. So AB is represented as 4x minus 5. So let's plug in 7 for x. 7 times 4 is 28, minus 5 is 23. BC is represented as 2x plus 9. Let's plug in the 7 that we found for the x. 7 times 2 is 14, plus 9 is 23. And it also asks us to find the measurement of the whole line segment AC. That was asked. 23 plus 23 is 46. That would be the whole line segment C. And it works out because AB is in fact equal in measure to BC. And that's what it should be because B is the midpoint. Each half should be equal. And finally, the last example here tells us that LM and PQ bisect each other at Z. What that means is that they cut each other equally in half since they bisect each other. So LM is being split into two equal parts, and PQ is being split into two equal parts. They tell us that LM, the whole segment LM is 5, and PZ, which is just part of the segment PQ, is that's 8. Writing the wrong measurement here. And PZ is 8. What can we conclude? Justify your answers. Well, since I know that PZ and ZQ are equal because Z is exactly in the middle, if PZ is 8, well, ZQ should be 8 as well. Remember, bisect means cut equally in half. So the point here that both of the line segments are being cut equally in half at must be the midpoint, right? Because that's where they're being cut equally in half. And we know a midpoint splits in the middle. So if this is 8, this must be 8. And so we can also conclude that the whole line segment PQ is 8 plus 8. It's 16. We know that LM, the whole thing, is 5. They told us that in the question. So since Z is also the midpoint of LM, LM is also being bisected as well. They're bisecting each other, LM and PQ. We know that LZ and ZM are half of the whole, half of the 5. So LZ is 2.5, ZM is 2.5. So those are some things that we can conclude there. Try this one yourself.